Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. In this slide, we read differential equation having one variable missing. In this type of differential equation, either the dependent variable y or the independent variable x is missing. With the help of substitution, a lower order differential equation is obtained from given differential equation. So let's see the first one, which is about dependent variable absent. This is the first case when dependent variable y is missing. Consider the second order differential equation where the dependent variable y is missing. This equation represents a second order differential equation where the dependent variable y is missing. To solve it, we take this lowest order derivative by p. We replace this derivative by p. Now differentiating this one, we get d square by d square is equal to dp over dx. Now putting the value, this will be replaced by p and this will be replaced by dp over dx. So the order of 1 is reduced by 1 and as of the form this one. This one has been replaced by dp over dx and this one is replaced by p. So this is the differential equation whose order is less than the original differential equation, which is of order first, and p and x it can be solved for y as a function of x. This method is also used for higher order differential equation. This is a higher order differential equation and this is the ordered derivative of y with respect to x. So we will replace this by p to depress the order by 1 and proceed to solve the reduced equation for p and finally find y. This second slide, and here we will discuss an example. Solve this third order non-homogeneous differential equation. Here we have a third order non-homogeneous differential equation. In this differential equation, these are the conditions, these are the initial conditions. So this differential equation is initial value problem. In this condition, here we have the same value of x and different value of the other. So it is initial condition, and this differential equation together with this condition is initial value problem. In this differential equation, the dependent variable y is missing. The dependent variable y is absent. Let this lowest order derivative be replaced by p. Now differentiating, we get this will, the order of this after differentiation will be third and it will be dp over dx. The given equation becomes, now putting value of this, which is p. So this will be replaced by p and this will be replaced by dp over dx. The given equation becomes, this x will be here again and this third order derivative will be replaced by this first order derivative, which is here. This will be replaced by this p and this 12x cube will be as it is. Now differentiating both sides by x, so this is the simplification. If we study this differential equation, it is linear differential equation in p. It is linear differential equation in p. So we minus 2 over x, we will use minus 2 over x for integrating factor. So integrating factor is e power integral minus 2 over x. This minus 2 will be taken out here. Integral 1 over x is log x, and this can be written as log of x power minus 2. This will be cancelled, we get x power minus 2 and it is 1 over x square. So for this differential equation whose integrating factor is 1 over x square, this 1 over x square is the integrating factor. The general solution is p. This p will be written here. P into integrating factor is equal to integral of q. This q is equal to 12x square. Integrating factor dx plus c, putting the values. So this is p, which is here, and this integrating factor is 1 over x square, which is here. This q is 12x square, which is here, and this is integrating factor. Simplifying, these two will be cancelled, so we get integral of 12 dx. 12 dx is equal to 12x plus c. Now simplifying this equation, this is the simplification. Now putting value for p, this is p, here we see value of p, so putting d square y by d square is equal to this one. This is the new differential equation. For this differential equation, this is the condition. Now using this condition, x, when x is 1, then y double dash is 0. Here x is 1, y double dash is 0, so putting this condition here, this is 0 and x is equal to 1. So finally we have c is equal to minus 12, putting c is equal to minus 12 here. This is the result. Now integrating both sides, so this is the value. Now using the initial condition, this is the second initial condition. When x is 1, y dash is equal to 1, so here when x is 1, y dash is 1, so putting the value, this will be 1, and for x put x is equal to 1, so finally we get c1 is equal to 2, putting c1 is equal to 2 here, so this is the value. Now integrating both sides, if we integrate this equation, so we get this is the value. Now for this we have the integrating condition, initial condition. When x is 1, then y is 0, so putting this initial condition in here, we get value of y is 0, and putting for x is equal to 1, and this is c2. Now simplifying, value of c2 is 8 over 5 minus 8 over 5, putting minus 8 over 5 for c2. So this is the required general solution, taking 1 over 5 common, hence this is the solution. So here we studied a differential equation where the dependent variable y was missing. We replaced the lowest order derivative by p, and we proceeded the solution. Now we have another case, independent variable absent. By the independent variable we mean when x is absent. If the independent variable x is missing, as follows. Here we see nth order differential equation where the independent variable x is missing. Here the lowest order derivative is dy by dx. The substitution dy by dx is equal to p reduce equation 1 of order 1. However, to get a differential equation in y and p, we express the r derivative in terms of p and its derivative with respect to y. To do so, we proceed as here this dy by dx will be replaced by p. This is the differential equation where x is absent. This lowest order derivative will be replaced by p. So here dy by dx is equal to p. Now the second order derivative can be written as d by dx of dy by dx. Now this dy by dx is p. So we get d by dx here. This is the second order derivative which is equal to, which can be written as d by dx of dy by dx. Now this dy by dx is equal to p, so we get this one. Now we can write this one as dp over dy, and now this dy by dx, this is dy by dx which is p. So for dy by dx we will put its value which is p, and this will be written here, and hence we get d square y by d square equal to p into dp over. Now writing the third order, this is the third order which can be written in this way. So for this we will put its value. For this is the value, so putting the value. Now this dx will be shifted here, and we will put dy here and here. Now here we see product of two functions, so using product rule, and this dy by dx will be replaced by p. So this is p, and for this is the value of the product rule. Now simplifying, this p into p will be p square, this will be here again, Now these two will be square and this p will be written here. So here we have got the values. First value, this is the second value, this is the third value. First order derivative will be equal to p, second order derivative will be equal to p into dp over dy, third order derivative will be equal to this one. We have to remember these three results. This substitution reduce the order of given differential equation by 1, and the reduced equation will have the variable p and y, and the equation is solved by the known methods. Note: if a differential equation is free of x and y, both apply either a or b. If we have a differential equation where both x and y is missing, then we can use either the first method, which was a, or the second method, which was b. Differential equation where the independent variable x is missing. In this differential equation we do not see x. यहाँ पे इसी डिफरेंशियल इक्वेशन में इंडिविजुअली x हमें नज़र नहीं आ रहा है. हमें यहाँ पे x नज़र आ रहा है, लेकिन हमें इसी x को नहीं देखना है. हमने देखना है कि कहीं यहाँ पे या इसके साथ या यहाँ पे कोई x वगैरह तो नहीं है. सिर्फ इसी डिफरेंशियल इक्वेशन में y नज़र आ रहा है, लेकिन x नज़र नहीं आ रहा. लिहाजा ये सेकंड केस है, यानी b है. x is missing. The independent variable x is absent. अब यहाँ पे lowest order derivative, we will replace this lowest order derivative by p. Now this second order derivative will be p into dp over dy. ये नेक्स्ट प्रीवियस स्लाइड में जो वैल्यूज थी उसको हमने याद रखना है. देख ले, इसी सेकंड ऑर्डर को हमने इसके बराबर लेना है और इसको याद रखना है. इसी तरह इसी थर्ड ऑर्डर को इसके बराबर लेना है और याद रखना है. तो इसकी वैल्यू यही है और सेकंड ऑर्डर की वैल्यू यही है. अब इन दोनों वैल्यूज को यहाँ पे पुट करना है. इक्वेशन 1 रिड्यूसेस, तो इसकी जगह हमने इसको पुट किया और इसकी जगह हम क्या पुट करेंगे, इसी p को पुट करेंगे. और ये पावर 3 है, इसकी जगह हम इसी को पुट करेंगे तो ये आ गया. अब यहाँ पे सिंप्लीफिकेशन डिवाइडिंग दिस इक्वेशन बाई p, तो ये आ गया. अब इसी इक्वेशन को हम इस तरह लिख सकते हैं, सेपरेटिंग द वेरिएबल. नाउ इंटीग्रेटिंग बोथ साइड्स, सो हियर वी हैव इंटीग्रल ऑफ दिस क्वेश्चन इज tan inverse p, इंटीग्रल ऑफ दिस क्वेश्चन इज tan inverse y, इंटीग्रल ऑफ 0 इज कांस्टेंट. अब इसको हम इस तरह लिख सकते हैं. इसी tan इनवर्स को हम दूसरी साइड पे ले जा सकते हैं. tan c एक कांस्टेंट है, इसको हम रिप्लेस कर सकते हैं बाई c1. अब इसी इक्वेशन को हम इस तरह लिख सकते हैं p प्लस वाई, और इसको हम इस तरह लिखेंगे. फिर इसको मज़ीद हम इस तरह लिखेंगे और यहाँ से हमने ये लिखा. अब इस यहाँ पे p है, तो नेक्स्ट स्लाइड में हम क्या करते हैं, दिस इज वैल्यू ऑफ p. दिस p इज एक्चुअली dy बाई dx. नाउ सेपरेटिंग द वेरिएबल, दिस इज द रिजल्ट. नाउ c1y के साथ हम माइनस c1 स्क्वायर प्लस c1 स्क्वायर लगाएंगे और फर्स्ट टर्म को हम c1y माइनस c1 स्क्वायर, c1 कॉमन निकालेंगे तो y माइनस c1 कैंसिल होगा और ये c1 अब बचेगा. इसी 1 के साथ 1 प्लस c1 स्क्वायर लिखेंगे और इस पर डिवाइड करेंगे. अब इंटीग्रेशन आप c1 लेंगे, इसके इंटीग्रेशन लेंगे और यहाँ पे इंटीग्रेशन लेंगे. इसका इंटीग्रेशन c1y है. यहाँ पे क्या है, दिस इज 1 प्लस c1 स्क्वायर, ये कांस्टेंट है, और y माइनस c1 का डेरिवेटिव 1 है. यानी हम यहाँ पे लॉग डिनोमिनेटर का फार्मूला यूज़ करेंगे. यहाँ पे इंटीग्रेशन यही है, ये कांस्टेंट है. अब इसको हम मज़ीद किस तरह लिखेंगे, इसी माइनस x को हम यहाँ पे लिखेंगे और बाकी इस तरह लिखेंगे. दिस इज़ द रिक्वायर्ड सोल्यूशन.